Now, so 12.3 is kind of a combination of the trig stuff we did in 12.1 and then angles in standard form in 12.2. So we're going to kind of put that together. And in order to do that, we've got to know a couple things. First off, what we're going to be talking about are theta, an angle in standard position, and then there's going to be this point that's going to lie on the terminal side. Okay? And we're going to essentially form a right triangle using the terminal side and the point, and then once we have that right triangle, we'll have our opposite adjacent hypotenuse, and then it's just a matter of plugging that in and coming up with our trig functions. So as an example, okay, here is an angle theta, some point xy. I decided to put it in the first quadrant just to keep our numbers simple. Okay, so our x is positive, our y is positive in the first quadrant. Here's my angle theta. We don't need to know what the measure of it is. It's not important. But a big chunk of what you're going to be doing in 12.3 is creating triangles knowing that you have a given point on the terminal side of the given angle. The next part I want to do is form the right triangle. Okay? And so what's going to end up happening is this is going to end up being our hypotenuse. But because I know x and y, I know the horizontal and vertical distance. So just let me show you what it kind of looks like. So we know that this vertical distance is y. This point is y high. Okay? And then x long. Okay, that's how we get to the point xy. We move from the origin to the right x and up y. And then here you can see where my right triangle is going to be. Okay? And then what we do for the hypotenuse, we actually, instead of saying A, B, and C like we'd think of for a Pythagorean theorem, we're actually going to call that length R. Okay? So when we deal with a point on the terminal side with respect to an angle in standard position, our sides are going to be X, Y, and R. Okay? And this is a right angle here. And once we have that right triangle, then we can come up with all of our trig functions with respect to angle theta. What is y? Which side is y in respect to angle theta? It is the opposite side. Okay. What side is x? With adjacent, and then r is, of course, our hypotenuse. Okay. So whenever I have a point on a terminal side of an angle in standard position, I can come up with all the trig functions in general. Okay, so for example, okay, the sine of theta, opposite over hypotenuse, the opposite is y, the hypotenuse is r. What's the cosine going to be of theta?
The x over r.
X over r. Okay. The adjacent side over the hypotenuse. So what's the tangent going to be? Tangent of theta is?
Y over r.
Opposite over adjacent.
Which is, in this case, y. Okay. Then write the other three. What are the other three? What goes with sine? Cosecant. What goes with cosine? Secant. And what goes with tangent? Okay, so write those over here. So here are the, hopefully you got those: cosecant, secant, and cotangent. It's just, again, the reciprocals. How many had those? All right.
I did.
Okay, so in general what we're going to be doing is you're going to be given a point. And a point with actual numbers in them instead of just a general x, y. And then you're going to do this with that point. So let me show you an example of one that you're going to do like that, okay? So here's one. And if you want to take a picture of that instead of writing it all down, you're welcome to do that. And we're going to walk through this whole problem about what you're supposed to do and how you figure out the 6 trig functions based on a point. The biggest difference is that instead of having a generic xy like I did in that first example, we have an actual x and y. Okay, so what you want to do is start by graphing that point. And once you graph that point, you have your x, you have your y, we have to find r. And once you have x, y, and r, you can simply write each of those functions like we did on the other page, but it'll have numbers in it. So let's kind of walk through that a little bit. So here's what we're looking at so far. Okay, I've got my, I'm going to start from the origin, and I'm going to go left 3, that's negative 3, because that's what my x value is. Okay, and then which way am I going to go from here?
Down 4.
Down 4. Okay, so I end up in my point, negative 3, negative 4. And in the process, I have drawn my x, I've drawn my y. It is important that you keep the signs that are there, and notice that it's down in the third quadrant. Okay. My only problem is now I have to find r. Okay. So I have to find r. How do you suspect I'm going to do that?
Pythagorean theorem.
Pythagorean theorem. So go ahead and find r. Okay. Keep in mind, r is always positive. Regardless of what x and y are, r will always be positive. What is r?
5.
5. R is 5. Again, if I was using Pythagorean theorem up here, square negative 3, square negative 4, add them together, that is 5. Okay. Now, when I find the sine, cosine, tangent, and then the reciprocals, it's important that you pay attention to these signs because that makes a difference. Oh, so no, that's a good question.
How do you know which way to go?
Okay.
Yeah.
Well, we assume that the angle we're talking about is the one right there. That's formed at the origin, okay? It's at the origin, and is a part of that right triangle that we drew, okay? This is going to come into play in the next piece of this lesson, but that's a good question. It's always the one that is closest to the origin after you form the right triangle, okay? That's a good point. You could have just as easily just plotted this point first, kind of like I did on the first example. I plotted that point x, y, and then draw the vertical and horizontal parts. Okay, I just happened to do it along the way as I was plotting the point. I'm like, well, we got to go left 3 and down 4 to get to where the point is even at, so I kind of labeled it along the way. You don't have to. How you choose to do it is up to you, all right? Now, the sine, cosine, tangent, and then the reciprocal functions will all follow, and you will need to use x and y as negatives, okay? And one of the things that came up on the quiz, some of you got negatives for some of your answers on your quiz when you were typing in your calculator, and you questioned whether or not you could have that. And the truth is you can have that, and it's based off of where that angle in standard position ends up. Because we know down here, x and y are both negative in the third quadrant, which means the sine and cosine are going to be negative. If there was a point in the second quadrant where the x is negative but the y is positive, then the cosine will be negative and the sine will be positive. Okay? Over here, where the x is positive and the y is negative, the cosine is positive and the sine is negative. So that sine has to do where the terminal side of the angle in standard position ends up, which quadrant it ends up in. And so it is impacted, the trig function is impacted by what quadrant the terminal side's in. So in this case, since they're both negative, we know the sine will be negative and the cosine will be negative. So here's what you end up with. Sine is opposite over adjacent, opposite over hypotenuse. Okay, so the opposite is negative 4, the hypotenuse is 5, the cosine is adjacent over hypotenuse, and the tangent, negative 4 over negative 3, that just simplifies to be positive. And then these are all just the reciprocals of these. Okay, how many had those? Okay, good. Are there any questions about that? That's it for this part of it. Okay. The next part goes back to Jackson's question about which angle are we looking at. Let me draw that back in here. Okay. So this angle that forms with the x-axis is really kind of an important angle, and we're going to talk about what that is here in a second. So that angle that we formed is called the reference angle. Key thing, it has to be an acute angle less than 90. That's formed with the terminal side and the x-axis. It has to be formed with the x-axis. The biggest mistake people make when coming up with the reference angle is they try to form an angle with the y-axis. Please don't do that. It's the terminal side and the x-axis, and it has to be less than or equal to 90. Actually, it has to be less than 90, not less than or equal to, less than 90. So that theta that we drew on the last example was the angle formed with the x-axis and the terminal side. That was the reference angle. Okay, and a reference angle with respect to an angle in standard position is what we need to really refer to. Two other things that you need to keep in mind. So those of you guys who are taking pictures of this, just wait, because I got two things I'm going to add to this, and then you can go there. Okay. First off, if an angle is given to you in degrees, then the reference angle will also be in degrees. Now, if you want to convert it all to radians and work through it in radians and go back, you probably wouldn't do that. You'd probably work it all through in degrees and convert it back. You can do that. So the other part, if the angle is given to you in radians, then the reference angle has to also be in radians. So if there's a problem that's in radians and you want to work it out in degrees and convert it back to radians before you finish the problem, you can do that. Okay. Some of you like to do that when it comes to fractions and decimals. You like to convert everything to decimals, work through it in decimals, and then convert it to fractions at the end. You're allowed to do that. That being said, as you move on into more complicated math classes, particularly pre-calc, you're going to be expected to know how to work radians in that conversion chart I gave you yesterday is something you're going to eventually need to know anyway. This whole idea here is still about the same theme that we've been using about consistency. The problem has fractions, the answer should have fractions. The problem has decimals, the answer has decimals. If it's in degrees, it should be in degrees. If it's in radians, it should be in radians, okay? So let's talk about how to work through this and find reference angles and why it's important, okay? So what you're going to do in this situation, I want you to sketch the angle, so go ahead and do that. Sketch 210 degrees, okay, and then find the reference angle, okay. And once we do that and find the reference angle, I'll explain why the reference angle is important. All right, for the sake of time, I went ahead and put that one up there already, 210 degrees, and that's angle theta. If you start here and you go all the way over, you have to go to 180, and then you have to go how much further?
Like an extra 30.
An extra 30, okay? So the reference angle is the angle that the terminal side forms with the x-axis, okay? And it's got to be acute. So this terminal side forms two angles with the x-axis. This one here, so look at the screen, please. This is one of the angles that the terminal side and the x-axis form. And then this is one side, or one angle. The terminal side and the x-axis form this angle too. The problem is this is an obtuse angle. So that's not the one we want, that's not the reference angle. The reference angle is going to be right here. And that's similar to that problem where we had the -3, -4. Now, here's the reference angle, and we signify the reference angle by putting theta prime. It looks like it's got a little accent mark or an apostrophe or something.
So we can't.
It must be with the x-axis. Do not use the angle with the y-axis. That is a nothing. That has nothing to do with what we're doing. It has to be with the x-axis and the terminal side. And so again, the notation is theta prime. That indicates the reference angle. Okay? We already figured out how much this angle is. How much is it?
30.
30. Okay, because we came around to 180 and we had to go an extra 30 to get to 210. So the reference angle is 30 degrees. Now, here's why a reference angle is important. Okay. All the trig ratios that are associated with 30 degrees are also associated with 210 degrees, with one exception, or two exceptions in this case. Since the x and y are negative in this quadrant, the sine of 30 and the sine of 210 are the same, except the sine of 210 will be negative, but it will be the same value as the sine of 30. The cosine of 210 will be negative of the cosine of 30. They have the same trig values. They're based off of this 30-degree angle, but because of the position of where it lies on this coordinate system, the sine and cosine will be opposite signs from the sine and cosine of 30 and 210. Now that being said, because they're both negative, the tangent for 30 will equal the tangent of 210. Because a negative divided by negative is a positive. Okay? That's why reference angles are important, because of the relationship between the values of the trig ratios between 30 and 210 degrees. Okay? Any questions about this, or where this came from, or how to draw this? Or the notation for reference angle. Notice again the problem started in degrees, ended in degrees. So let's do one where it starts in radians. Okay? And this is where that that table, that chart, that diagram I gave you yesterday might come in handy for you. So here's another one. Negative 5 pi over 4. Sketch that, and then let's find its reference angle. Now just so you guys are aware, I'm going to work through this problem in radians the whole way. Okay? If you want to convert it to degrees, work through it in degrees, and then convert it back to radians at the end, you can do that. But I'm going to show it to you all in radians, just FYI. Alright. Since it's a negative, we're going to be going clockwise. And to get a better sense of what negative 5/4 is, I know that since it's an improper fraction, I know it's bigger than 1, right? And negative pi is the same as negative 180 degrees. Okay, so I'm going to go past 180, or I'm going to go past negative pi. And here's what I'm going to show you. All right. Negative pi is the same as negative 4 pi over 4, right? Because the 4's cancel. Which means I'm shy by a negative 1/4 pi. Okay, so what this means is I need to go another negative pi over 4 past, that really should say negative pi, but pi and negative pi are the same, still on the 180, right? So here's what it should look like. And here's what I mean by this. So if I start coming around, I get to negative pi, that's where my angle is, but I need a negative 1/4 more, negative 1/4 pi more. Okay, so my reference angle now is the terminal side with the x-axis. It's just this part right here. All right, well, how much further did I go past negative pi to get to the terminal side? I had to go an extra negative 1/4. Okay, so my reference angle in this case, all right, there's my reference angle there. Okay, so my reference in this case is pi over 4. Now here's why that's important. Because if you wrote negative pi over 4, you would be wrong. What kind of angle must the reference angle be? Acute means between 0 and 90. Or, when it comes to radians, it has to be between 0 and pi over 2. Okay, that's what acute is. So if you put negative pi over 4, okay, that doesn't fall in this range.
So it can never be negative?
It has to be acute, which means it's between 0 and 90, or in this case of radians, between 0 and pi over 2.
How would you do it?
Okay, so if you put it into degrees, this is negative 215 degrees. Yes, negative 225. Sorry, negative 225 degrees. So if you did that, then you go, okay, I got to go to negative 180, then I got to go another negative 45, and then you go, oh, this is a 45-degree angle, and then you convert it back to radians.
How do you convert that?
That's what we did in
It's not the
12.2.
180 over.
Yeah,
pi.
180 over pi, or pi over 180. Right.
Oh, okay.
What we did yesterday in 12.2. Okay.
Can we do that?
Yes, you absolutely can do that if that's the way you want to do it. Like I said, I didn't want to do it that way. I wanted to show you how it can be done with radians, but you are certainly welcome to convert this to degrees, work all the way through it, and then convert it back. But I also wanted to show you how to do it in radians, okay? And plus you're gonna have to learn how to measure angles in radians using just radians eventually. Not so much in this course, but in future courses you're eventually gonna need to know how to do that. So I wanna expose that.